with the desert areas around the higher peaks. So in the complex terrain, you'll see differences. You can see New Mexico. There's stripes of higher greenness probably at the higher peaks, and then some negative differences.
So I guess, and so I would say that you might have to use some of this. I mean, where you might have to define areas where your confidence in the product is less. Then the flatter areas, it's probably pretty good. But
we suspect that this is probably a fair representation of the horizontal variations on a finer scale than what is depicted by the climatology.
okay.
It's basically what the resolution of the product and the satellite data.
I think maybe the point you're trying to make is that
maybe
if
you should have a
wanted,
climatology that's at that resolution,
right.
then you would
That's
have,
correct.
then it would be good everywhere.
Yeah, we began producing this in summer 2010, so we just don't have the data to have an adequate climatology yet. But yeah, I've had that question asked to me before as well.
well, or you could just filter that or smooth it, whatever, to the same resolution as climatology, and then do the difference, and that would be a more like equitable.
Yeah, it's because of the resolution differences, it's not entirely fair to the climatology. But if you're running a high-res convection allowing model, you'd probably want to see scales of motion like this in your simulation as opposed to the smoother climatology.
So
That's my argument.
So you said the public version of work just uses the clima.
Yeah, the monthly climatology I showed up there is the.
Do like operational models or anything like use current data like this for vegetation?
Not yet. No.
I'll switch to 28.
The operational models are within 20 years of current research. They're not doing good enough. They have to be 20 years ago.
Which is largely a genetic difference.
So I'm just going to show -10 reflectivity forecast from just two members here. Show something interesting. This is the member that uses the MYNN PBL scheme, and this will be the ACM2 scheme. And this is at, let's just go back a little bit. Okay, 20, 21, 22, 23, 0, 1. So this member doesn't initiate anything until, go back. Right there. So there's 0, 1Z.
So about the time the aircraft are trying to return to Salina.
And then there's a giant cell. So try to keep in mind where these storms are initiating. This one, maybe Russell, Kansas.
Wow, the Kansas one.
There's 3Z, 4, 5, 6. And then now, this is a field that depicts the vertical motion at the diagnosed PBL top. And I'm going to start this in the morning. Keep your eye down here. Probably already saw it. 6, 7, 8, 9, 10, 11, 12, 13, 14. Something comes shooting out of, emanating from the dry line. Probably some gravity wave at the top of the PBL, I'm guessing. Then we go forward, 21, 22. You see in southwest Oklahoma, you see these horizontal rolls develop.
Yeah.
In Kansas, I think this is actually a roll. I don't think this is where the dry line is. I think the dry line is actually further back here.
Yeah, I think you're right.
And then the warm front you can see here. And then we go 23, you can see that even more well defined. And then watch the dry line here whack into these rolls in southwest Oklahoma, and that's about the time CI is in the model. And then same thing, we go up here, the intersection of this roll and the warm front is where that storm develops in Kansas. This is a really neat way of looking at the processes pretty much at the finest resolution that the model can handle what's initiating the storms. And this is something we saw in observations from the Concordia area the night before. There were a couple of horizontal rolls that were intersecting the front. And it was at the intersection of these rolls in the front that we saw CI occurring. But it's forecasting a similar evolution today in southwest Oklahoma. And then I guess I could stop there. The the other model had something similar, but was just earlier with initiation.
I have one question.
Sure.
Do you use the? I know in your discussion you use the HRR model run
Oh.
fairly frequently. So
You want to see that?
yeah,
Actually, I
might
have
have.
to show that. So
That would be nice.
So here's, let me just go back. This is a really busy image. We zoomed out today compared to what we usually do. So let's go to 17, 18. And the her draw line is their East Texas Panhandle. It actually doesn't push it quite as far east. So there we go. There it surges east there, 21. But we can see these rolls develop again a little bit further south in the her than they are in the caps runs, and then right there, 23 is where the her initiates the first storm. But again, it's the same process. It's the dry line surging into these region where there's well-defined rolls. And it's at the northern edge of that where we see the first storm.
Storms in Kansas also.
And then,
And-
here's the
and
Kansas
your
storm.
profit.
A little bit further west, and then unfortunately this stops at 23. That's all we had for this.
Oh, okay.
It looks
That-
like here the Kansas storm is on the dry line itself instead of out in front, out ahead of it. Do you think? That's farther west.
This is the dry line right here.
Yeah.
Yeah.
It looks like the.
And then it looks like it goes right here at the intersection
just
of
ahead of it.
a little bit northeast of there. Yeah,
Notice
roll.
there's a storm that looks like right along the boundary near Southwest Iowa.
Yeah. Oh yeah, forgot to show that too. Let me go over that quick. I don't want to steal your guys' thunder, but look, there's some interesting looking shapes.
Go back
up
one.
Right there.
There we go.
Omaha, Southwest Iowa that propagate strangely like a right turning supercell would propagate.
The only thing is it would be north of the warm front, so it probably would be slightly elevated.
Huh?
That could be riding the boundary.
Could be riding the warm front.
Unless the warm front's gonna get that far north.
Well, the her that you just showed looked like the warm front was actually all the way up to Southwest. I mean, that may not be right, but it
So,
does
yeah,
have
the
a storm along the
Close.
warm
The
front.
her is pushing the warm
Close.
front. Yeah, and it has that storm, and there were, I think, some NMM members that also had
Is that really gonna
a
happen?
nasty looking storm up there,
Well,
a little bit further south.
Maybe if
Where does it have it now versus reality? I mean, if we try to time up what's
Right now, if you use this, it's halfway through Kansas, the warm front is.
And what does the her have right now?
Yeah.
That
looks pretty close.
Pretty good.
That's pretty good.
That's
So,
surprising.
We'll see.
did you just want to see the her output? Or?
Yes, I just wanted
Okay.
to see the
All
output.
right.
I was-
And yeah, actually, I can do better than that. Let's look at, here's the temperature forecast. Here's 18. Yeah, it's pretty much right on the warm front.
Wow.
So does the her use that modus data? I mean, because it heats up the most where it says it's the driest.
Yeah.
Don't they have some indication of soil moisture in their?
It gets it from the parent model, which is the NAM. So it's whatever the NAM puts in there is usually what they put in.
Rapid refresh.
Yeah, what do they initialize up? Do they cycle the rapid refresh full?
Yeah.
Or do they reinitialize every 12 or something hours?
They'll reinitialize every hour, but I don't know what they use to reinitialize it for soil moisture.
They have some kind of an antecedent model that brings in like the stage 4 precip analyses. So it's going to have a knowledge about where the lack of rainfalls occurred and where recent rainfalls occurred to adjust the soil moisture initialization.
So, well, 1:30. We've talked enough. Let's go to your desk.
Well, let's briefly show the water vapor image again. This has 500 height from the rapid refresh analysis overlaid. 6 kilometer winds from bad for wind the area that we're concerned about, the heights are actually rising. And in terms of just upper level forcing, it's going to be pretty weak.
Yeah.
You know, potentially even slightly negative for initiation. So it's creates a lot of uncertainty as to the coverage of storms. But certainly there'll be some favorable environments for severe. Here's the surface visible satellite imagery on the surface ops. See that it's already warming up quite a bit. 95 over 65 in Childress, 92 over 70 in Altus. So it's there's going to be several hours of bubbling up there probably in that area. So probably a pretty good chance of initiating at least one or two storms there. And then that cloud shield has been retreating pretty well to the north, it looks like. If you give it another few hours, it'll probably be up near the Nebraska-Kansas border. And there'll be some threat there for initiation either along the boundary or just north of the boundary. There's certainly a risk of hail with any storm, and then if anything rides the boundary, could certainly be some tornadic activity also there, very large hail. I'll show a couple of forecast soundings, and then we'll talk about the high risk guidance.
One question.
Yep.
Is those clouds that are streaming from in the western part of Texas, is that going to be the source of where the storms will initiate from, or will it be other
Well, that looks like some altocumulus. It's hard to say if there's any sort of feature that's generating that. You know, maybe some slightly enhanced lapse rates or something.
Oh, okay.
Yeah, I mean,
It'd
there's
be
that
tough
whole
to say.
pocket of altocumulus
Yeah.
there that usually that's high up above.
Right.
And that's actually behind the
Fading.
dry line. It may indicate there's some little feature that's kind of progressing to the north there. But it's mainly going to be the surface dry line that's initiating storms.
Okay.
I'll show some forecast soundings from the NAM. Start in northern Kansas. This is Salina at 18Z. This is probably a little bit aggressive. Still only 70 in Salina. Looks like